In this video, I'm going to show you how to sketch a parallelepiped on a Cartesian space. So the three given vectors, OA, OB, and OC, are already on Cartesian space. They are respectively -2, 1, 3 for A, -2, 3, 1, 3 for A. So because of the angle of my third axis here, it turned out to be on x-axis, but it's just overlapping because of the angle of this one. Doesn't mean that it is on the x-axis. B is 4, -1, 3, and C, no, A is -2, +2 and 5, B 0, 4, 1, C 0, 5, -1. So those are the given position vectors. So we need to sketch the parallelepiped. First, we're offered to sketch it based on our understanding on what parallelepiped is, and then to find the coordinates of the vertices algebraically. So what's a parallelepiped? It's a 3D shape with all sides being parallelograms. So this is what we're going to use in order to sketch. So I'll take first the vectors OA and the vector OB, and I can see that they can form a parallelogram. So all I need to do is extending the other two sides of the parallelogram, which means I sketch one side parallel to the side which is represented by the vector OB, and the other one parallel to OA to get my next point. Okay. Now I will take the vectors OB and OC, and I sketch the parallelogram, which is based on which is formed by these two vectors. So it's gonna be a vector parallel to the vector OC. This is my first experience, by the way, of drawing in smooth draw, of graphing in smooth draw. As you can see, it's not that easy. Okay, I'll try again. So I need to sketch a line which is parallel to OC, and the other one which is parallel to OB. Oops, again, not working that well. Okay, so as a rough approximation, it's gonna be something like that. Okay, so this is the parallelogram which is formed by the vector OB and OC. Now, what other vectors we didn't use yet? We didn't use the vectors, the combination of the vectors OA and OC, right? So they can also form a parallelogram. So let me use a different color for this one, because I don't think it will be clear if I use the same color. So let me use this green, light green one. Okay. Let me see if it's gonna look good. Right. So I'm going to see what parallelogram can be formed by the vectors OA and OC. So I'm going to sketch the side parallel to OC first. Okay, it's going to be something like that. And the other one, which is parallel to the side OA. Right, so this is what I get. Now, to complete this way, I have, if you can see that, I have only 3 sides of the parallelepiped, but any 3D shape like prism or parallelepiped or cube, they have 6 sides. So how to sketch the other sides? Let's go back to the red color. So if you look at, let me put points here, let it be vertex F, vertex D, and vertex C. Okay, this will be vertex C. So what I can do now, I can see that I have BF and BD as the other 2 vectors now. They're not position vectors, but they are forming a parallelogram as well. So I'm going to sketch the parallelogram. In what way? By sketching the sides parallel to BF and parallel to BD. So parallel to BD should be going down from F like this, and the other one going now I'm going to sketch the one parallel to BF. Right, so this is another one. Okay, so I need to then connect these 2 points together, and that's it. This is my parallelepiped. Let's make sure that we have all the points on place. K. Okay, so we have to have 8 vertices. As you can see, I have 8 vertices at the top and 4 vertices at the top and 4 vertices at the bottom. That's how parallelepiped would look like. It might not look exactly like the answer in the textbook, simply because the angle of the third axis, the x-axis, is different from a version to another one. That's why you should not be focused on how the answer looks like.